Okay. So here we're kind of mixing up odds and probability. So I need you to understand, first and foremost, on your study sheet, you need to read carefully when it comes to probability. Okay? Probability, you will always have a fraction or something like that, usually a fraction. When it comes to odds, it's different, correct? You have to have the colon there, and you have to have a number and another number. Okay, so that's the first thing I'm going to ask you to please read carefully. Is it probability or is it asking for odds? Because if it's asking for odds, you have to have the colon there. Make sure you remember that. Odds need to be stated. There needs to be the word of, for, or against. Okay, so it's saying the odds of this happening or the odds against this happening. So we compare desired and undesired events. We don't have a total here. I know I'm going to repeat myself, but it doesn't hurt. So these are three different ways to think of odds. This is probably the most popular right here. That the number on the left is events in favor. On the right side is events against. Okay. This is what I want you to remember, that when you add these two up, you get your total. Okay. So no total when it comes to odds. I will probably ask you to come to a different page, and I will fill this in one more time. But remember, if it says odds in favor, then this number is obviously the amount of times that it's going to happen. Against, this represents the number of times it's not going to happen. Okay? So it's for, against, like that. If I asked you to state the probability of it snowing, so let's say you have probability of snowing, not snowing. If I ask you from here to state the probability of snowing, you put this green number up here, and guess what? The bottom is always the addition of both of them. That's going to give you your total. If I ask you to state the probability against something happening, so no snow, you take this number, okay, that is going at the top, and guess what? You still add up these two numbers to get your total. That is always going to stay the same. So, I'm going to ask you to go to 16 there, and I don't know how much you filled in. Maybe you just need to follow along. I'm not sure where you're at. But maybe pay attention to the little details that I may add that you haven't heard of or that maybe you forgot. So if it says the odds of, first of all, odds, you're expecting it to be in a certain format, and it's saying of the Jets winning. So because it says of, that means that this is winning and this is not winning. Immediately when you see it this way, that's what that means. Explain what the numbers represent. So 8 is the number of wins. You can say it that way if you want. 2 represents the number of losses, right? And we are out of 10. It's always, in this case, we would consider 10 games, 8 wins, 2 losses. Okay. State the odds against the Jets winning the game. If the odds of winning is here and then against, all you need to do is flip it. Flip original. I know I probably original. There. So basically just flip it. You don't need to, sometimes students, when I ask you to do this, they add, subtract, they do all kinds of fancy stuff. If you have the odds of, the odds against is just flipping it. That's all it is. And that is sometimes what we ask you to do. That's it. Like a lot of these questions can be answered in less than a minute. Okay? What about this? This is the skill I need you to make sure you understand. State the probability of the Jets winning. Probability of the Jets winning. So we go with this. These are our odds, and we know what the numbers represent. You should show me this, that you're adding 8 and 2, because you're stating a probability now. And in this case, 8 represents the number of wins, so we put that on top. So this would be 8 to 10. I can almost guarantee you that there'll be something like this on the test, just different context. So this would be the probability of winning the next game. Probability of losing, you've got a choice here. You can go, if 8 out of 10 is winning, then obviously 2 out of 10 is losing, right? It's just, or you could have gone back to this and be like, well, probability 8 plus 2, right? You got to add these two. And in this case, not winning or losing is the 2, so you put that on top. It's still 2 out of 10. No matter what you do, whether you go back to the odds or you go back to the probability of winning, regardless, you should get this. Okay. I think that's all I'm going to say for this page. Are there any questions about 17, 18? Was it pretty clear? Were you able to follow? Yeah? Okay. It's all muffled sometimes, my videos. I know it's something to do with the mic. I apologize for that. I'm just going to say page 18. This is fresh. This is very fresh. Page 18. You have to know what a multiple of 4 is, or a multiple of 5, or 10, or set, whatever. You need to know what that is. A multiple of 4, right? You start with 4, and then you go up by 4. Okay. And this would, I can't do this. I didn't read the question. It's 1 to 12, right? Up here, 1 to 12. The province stole this question from me. They had literally this exact question last exam. They were saying, hey, you have a number 1 to 12. What's the multiple of 4? And in this case, because we're sticking 1 to 12, right? That's all we have to go by. 4, 8, 12 are the only applicable scenarios here. Okay. So on your study sheet, maybe if it says multiple of 4, have like this. Obviously would just keep going, comma, dot, dot, dot. You would just keep going with that. The probability in this case, you've got 3 favorable outcomes. These are all multiples of 4. And then 12 are your total number of outcomes. Always make sure the bottom number is bigger than the top when it's probability. Always. Okay. You may want to add that to your study sheet. I'm going to ask you to 21. I think I stopped at 20, I believe. So let's go to 21 here. So we're going to go the other way. We're going to go from probability to odds. I'm going to say, for now, I'm going to say if you don't have anything else, I would say at least have this boxed in and make this appear on your study sheet. The same I would say with what's on page 16. I have one like that goes on 16, similar fashion. Okay. All right. If I give you a probability and you're supposed to write the odds, this is kind of like the template you can follow. Okay. Do you want? I think I'm going to put numbers right next to this. Okay. So let's say the probability that Mr. Dirksen teaches is 3 out of 5. Okay, there are 5 days in a week, and out of those 5, I teach 3 out of 5 times. The other times, I just let you write an AC, or I call in sick, or whatever. Okay. If I asked you to write the odds, okay, we're going to go arrow here. Odds of teaching. And here we're going to go odds against. It's small, right? Sorry about that, but I want it to fit on your study sheet. Odds of teaching, odds against teaching. Watch this. You would go 3. Okay, you grab the 3. Those are the amount of times that I do teach. And on the other side, this is what most of my students do. On the exam, they just go 3 to 5, obviously, right? Because those are the 2 numbers that are here. obviously those are the two numbers that go over here. And this is wrong. If I teach 3 out of 5, then I don't teach 2 out of 5, correct? So this should be a 2. And the best way to do that is to just go take the 3 away. The 3 you already used. Take that away from 5. So that turns 3 to 2. These are the odds here. Okay? Julian. Oh, okay. Probability that Julian sleeps through the class. Odds against, I would just flip this one. I would just flip the odds here. It's 2 to 3. And then you're done. So you should see a connection. Okay, you should see a connection there, and I'll leave it at that. Before we start, I'm going to do at least 2 examples. I'm going to skip the first one. Okay, plane crashing, I'm going to skip that. The reason why, it's a really big number, it's going to throw you off at first. So let's go to this one here, straight to this one on page 21. Okay. The probability of a student passing the probability unit test is 95%. If you can, write it as a fraction. 95 over 100. There you go. Do it right away. Just get it out. I love fractions when I'm dealing with odds and fractions. I just like to stick with a fraction. What does it say here? State the odds of a student passing. Before we put numbers, how about we do this? If it says odds of passing, that means that pass, that number should go first, and what should go on this side? Fail, or can I say pass not? We're going to go Hamlet style. You shall pass not, right? Anyways, pass and pass not. So what number, we would grab the 95, because that represents the number of times you pass. That goes here. And what would go over here? 5. However, I'm going to make it complicated. I'm going to go total minus 95, right? Because 95 pass. I'm going to take that away from my total. But if you knew that 5 had to go here, you're good. Like, don't make it complicated. This, the province would give you full marks for that. However, I don't know if I talked to you about the multiple choice. It could have been that the province sets this question up for you and then has multiple choice, and you may not see this one. So you need to know how to reduce this one. Here's my cheat for you, okay? I'm going to do the cheat first. You write it like a fraction. Watch this. 95. And then you see this button. I don't know if you have the fraction button on yours. I'm going to press it. And then hit equals. Wait. It doesn't work this way. You have to go smallest top and then largest second. Let's try that again. 5, 95. So it'll be 1 to 19. However, don't mix it up, right? You know that this is the bigger number. So 19 to 1 is the reduced. Is that a good cheat? I'm not sure. Let's try this one. This is what most of you learned in junior high probably. 5 goes into both of them, correct? So you just go divide it by 5, divide it by 5. If you see that, just go ahead. Like 5 divided by 5 is 1. 95 divided by 5 is 19. So that's another way of doing it. If you want to use the cheat, you just got to make sure the smallest gets entered first and then the largest, but don't mix it up, right? Like you got to make sure that the biggest number goes here and the smallest there. So that's how you write the odds, okay? State the probability against a student passing. Probability, right? Notice that. It has to be a fraction. I think we can just write this one 5 over 100, right? Like if 95 passes, so 5 over 100 is not passing. However, You could have also done this, or because it's a probability, you could go 100% minus 95%, and that leaves you with 5%. Both are acceptable here. You could also turn this into a decimal if you'd like, and that'd be 0.05. So it all means the same. State the odds of a student not passing the unit test. Against, write that down. It's the same thing. A student, state the odds against a student passing. That's what's happening here. Do we have the odds for passing? Yep, right there. So don't do anything fancy there, just flip it. Okay? Flip original. So 1 to 19 are the odds against passing. Okay? All right. Let's go to 22. So you got to be comfortable going back and forth between probability and odds. So watch how this is going to unfold, okay? This is where everything meets. The odds against a smart TV being defective from factory are 2,000 to 3. Hold it. It says what? Against. Against what? A TV being defective. This is the event that we're talking about. So if it says odds against TV being defective, where is the defective going to be? Which side is going to represent the defective TVs? The 3, because it says against, okay? So this is defective, and this is not defective, right? Good. I'll just call that good. They work. Okay. So that is important to determine which number is what. And it's all based on the wording. That's why this is a little tricky. Okay. If the company produces 64,000 TVs per month, how many would be defective in a year? I'm going to recall something here. We're making a prediction. Therefore, we need the probability. Right? So let's do that. 20,000 to 3, right? That's going to give us a probability of defective. Let's do the easiest part first. Let's add them up. You're going to have to add them up down here. Okay? And the 3 is going to go up here because that is the amount of times it's going to be a defective TV. So we go like this. Okay? That's my probability. You want to turn that into a decimal? You go for it. I wouldn't. I would just leave it like that. Because if they don't ask me for it, I just leave it like that. So now we make our prediction. This is a 2-part question. We're going to go probability. Yeah, I don't blame him. 64,000 TVs, right? So this is a probability of being defective. You're making 64,000. That's going to give us a number. So let's go ahead and do that. 3 divided by 20,003. Very small number. Don't worry about it. Multiply that by 64,000. So there's 9.5985 something TVs defective. In a month. They want for the whole year, correct? So we'll do that. We'll just multiply this by 12 months. and then we will round. Okay, so we go times 12, that's 115.1827 something. So we have to round. So what would you say? Well, the nice thing is you get to say 115 or 116. I would go with 115 most likely. Actually 116, right, from the company's perspective. Let's make sure we're not being too generous. We have actually a bit like an extra defective TV. But as long as you do rounding, you're fine. Okay. So the important part is to know where to put the numbers. Okay. Mr. Dixon, there was way too much going on. I get it. I get it. But we went from odds to probability. That's a very important skill today. This part, the prediction part, we've done before. So I inserted it here to review. And then the part where you have to multiply by 12, obviously that's a little bit of an added, but I would expect you to be able to do that at this point. I will give you a summary of this in a bit, okay? I need you to do a little bit of work as I walk around. I just want to make sure you understand what's going on here. So we're going to say 22, just 22 for now. And then once you do that, I'll cover a bit more, okay? So just finish. I didn't assign this yet, did I? I don't think so. Just do this part right here. And if you're done this part, I want you to do the plane question, the crashing plane here on page 21. It's a little weird because the numbers are so big, but if you stick to the plan, you should still be fine, okay? So try this example right here. Shouldn't take you too long, page 22. And if you're not sure, I'll help you out. Figure this out. State the odds of going blind after surgery. Okay. So we've got that the probability of going blind after laser surgery is very small, right? So odds would be 1, 2. That's what a lot of students do. Okay. So on your study sheet, you should have, you know, if you've got maybe even just a quick example like this, 1 to 10, right? You would write 1, 2, 10 minus 1, that's 1 to 9. Just a quick thing on your study sheet. Yeah. Go ahead. So we're going to go minus 1 here. So you go 4,999,999, like that. This is the correct. So you might be like, it's off by 1. What's the big deal? It is actually a big deal here. Okay. Whether or not we see that you're doing this is a big deal. You should always be able to check. If I were to add these two, do I get that denominator back? And in this case, you do. If you were to leave it like that, your denominator would be 5,000,001, right? If you were to try to go back to the probability. So that's something you want to check. Odds against, you just flip it. That's all it is. Don't be doing anything weird, okay? Like I sometimes see students taking this and going minus 1, like you subtract. That only happens when you go from probability to odds. Once you're in odds, don't do that anymore. Within odds, you just flip it, okay? State the probability against going blind after surgery. This is where you have to be careful. I would say this number is going to help me out right here, the 4,999,000. But I need you to understand that it's not like this. If you ever see that, this is very wrong, okay? Because this always has to be bigger, okay? So I'm going to use this one maybe. I'm going to say 1 plus, right? Go back to, you don't have to show me this necessarily, but I think it's for you to see what happened, okay? So this is over 5 million. That is it. Could you have stated this as a decimal? Yes. So if you go 4,999,999 divided by 5 million, right? That's what you get. But the thing is, you have to be careful. Don't round this to 100%. because it will be wrong. You cannot say 100% because it isn't 100%. Okay, so then your only alternative would be to state it using all decimals here, or you go times 100, which would be 99.9999998%, right? So don't round it to 100%. My suggestion would be leave it as a fraction. That is your answer right there. Let's go to the airplane real quick. Plane crashing, or hopefully not crashing. There we go. Too many. Every time I'm on a plane, I'm always thinking all the things that can go wrong. I'm like, this big thing is up in the air, right? 30,000 feet above the air. It's like, yeah. Anyways, the probability of a plane crashing is estimated to be 1 in 11 million. State the odds of the plane crashing. So odds, that 1 goes up front, and then this would just be 11 million minus 1. Okay. So it's 10,999,999. That's just to drive the point home. Okay. Odds of the plane crashing. Odds against, I just flip that. And I'm going to just give you a heads up here. The province is very, I've seen it quite often that they don't make you do this first. They just go straight, the probability of the plane crashing is this. What are the odds against? And my trick for that would be just put the 1 here, because that would make it against crashing, like, right? Crashing would be here. And then just go 11 million minus the 1 to fill in the rest. Or you might want to go the loop. You might want to find this, then flip it. Okay. So just flip. Okay. There you have it. Let's go to 23, and then I'll let you do a little bit of work on your own here. You need to be able to tell me which event is more likely to happen, which one has a higher chance. And the best way to determine this, I'm going to highlight this part. You should probably have this on your study sheet. The best way to determine is to actually figure out the probability as a decimal or percent. Fraction is very hard to tell which one has the higher. So decimal or percent, whichever one you pick is fine, but I would have them in this format. A higher value indicates a higher chance of that happening. So let's give this a try. We bring everything together, okay? The odds of being attacked by a shark, I just Googled this, okay? So if this is wrong, I apologize. The odds of being attacked by a shark would be 1 in 3 something million. The odds of coming into contact with hornets is 1 in 54,000. In this case, it's actually pretty easy to figure out which one is more likely to happen, right? Being attacked by hornets. But let's just focus on the steps that are involved here. We'll state the probability of being attacked by a shark. So probability of shark, you don't have to do this, but we'll just figure it out. That's 1 over 3,748,067 plus 1. Okay. So that's 3,748,068. And as a decimal, watch this. It's going to be pretty crazy. And I hope they never do that to you. Not that it would matter. You should know what to do with this. But yeah, it's a very small. So I'm just going to state them all. 6 zeros. Followed by 266. I'm just going to use all of them. Leave it at that. If you multiply that by 100, you would lose a few zeros. You'd have the percentage at the end. The probability of being attacked by hornets, that would be 1 over 1 plus 54 0.093. Okay? So I'm adding these up to get my denominator. So we get 1 over 54,094. Let's turn that into a decimal. Look at that. There's four zeros. 1, 2, 3, 4, 1, 8, 4, 8, 6. Which one is bigger? This one, right? This one has 6 zeros, so that's obviously smaller than this. This one is larger. Okay, more likely to happen. But let's say they both had four zeros, right? Then you would go to the fifth and compare both, like at the fifth decimal place, and whichever one is larger there wins. Okay, is the most likely to happen. Which is more likely to happen? We'll just say getting attacked, being attacked by hornets because the probability is greater. That's all you need to say. That's why you know the probability is greater, and you've mathematically shown that it is. One more example. So what's the skill behind here actually is going from odds to probability. The odds of Xavier being late is 4 to 9. The odds of Nina being late is 5 to 14. I'm just going to say this. If you're highlighting, both of them are saying of. So be careful if I say against. You have to kind of be mindful of that. So probability for Xavier, figure that out. Probability for Nina, we're going to figure that out. Xavier is 4 over 9, correct? That's easy. And Nina is 5 over 14. That's easy. Is that correct? It's not correct. No. I hope you caught it. You can't just put the 9 there. It's not correct. You got to go 4, right? 4 plus 9. Like that. So it's 4 over 13. This one is, right, 5 plus 14. So it'll be 5 over 19. Now you're talking. Now you have both probabilities. So Nina was late Xavier is 4 out of 13 times late. Nina is 5 out of 19. I don't know if you can tell which one is higher. I would say the easiest way is to turn that into a decimal. So that'd be 0.3077. 5 divided by 19, 0.2632. And I hope that at this point you would be able to tell more, right? More likely to be late. Xavier is more likely to be late. All right. I'm going to pause here for a bit. I'm going to ask you to try 24 to 25. Okay? 24 to 25. And while you do that, I'll hand back the tests. I'll let you work a little bit though first. So try it. And if you need to quietly consult with your neighbor, that's fine. Try page 24 to 25. And then I think I will give you like a summary for your study sheet to have under probability. Looking up and quickly checking off if you got this right. I think the first couple we already had, right? Drawing a red 7, there's only 2 out of 52. Jack, they're 4 out of 52. Because they have the same denominator, we didn't really have to resort to turning them into a decimal, but I did anyways. Rolling a face, there are 12 face cards out of 52. Rolling a 5, it's 1 out of 6. Okay, so you gotta make sure you pay attention how to set them up. Club face, or the spinner landing on yellow. There's only 1 out of 8 that are yellow. Club face card, why did I have 3? Oh yeah, I know now. Because club has Jack, Queen, King. I was a little confused there for a bit. We got it. Rolling a multiple of 3. So it's implied that it's a standard die unless I tell you differently. So 3 and 6 are the only 2 that are possible, that are multiples of 3. And so you got 2 out of 6, right? Which is 1/3, which is 33.33. Probability of landing on green, based on this, there's 2 out of 8 green sections. So it's a quarter. It really comes down to the decimal or the percent where you know for sure. Okay? Red card, or the spinner landing on red. There's 3 out of 8 on the spinner, 26 out of 52, that's half. So obviously getting a red card is more likely to happen. By the way, this is only true if you do tons of experiments, okay? That's coming up next. Here you go, guys. Look at the on 65 here. I'm mixing it up on you, right? There's a 45% chance of winning for the Bombers, and the Elks is 7 over 9. So first thing, I give you probability in different formats. You get 45 over 100 for the Bombers. Elks. Oh, wait. Chances of not winning. You're paying attention, right? So not winning is 7 out of 9, which means that winning is 2 out of 9. So what I do there is I turn, what should I have done here? Write the probabilities as odds for and against winning. So if 45 out of 100 you win, then 55 out of 100 you lose. Okay? The odds in favor would be 45 to 55, because remember, you always go denominator minus the top to get the other number. And I just flip this. The easiest thing would have been to just flip this to do the odds against, right? Against winning. For probability of winning, I turn that into 2 to 7, because you go 9 minus 2, and then 7 to 2 here. Okay, so the odds in favor and against. Here we have 3 different schools, Sisler being one of them, and we're trying to figure out which one is more likely to win given all these 2 schools. We have the odds, the MCI, we have the probability of it. Okay, so we turn Sisler's odds into a probability. Remember, I add 9 and 17 to give me 26. Turning it into a decimal or percent, I have that. Calvin, I do the same thing. I add it up for my denominator, turn it into a decimal or percent, slightly lower than Sisler. And Daniel Mack, watch this. It is already a probability. It's not saying 4 to 15. It's saying out of 15. Right? Pay attention to that little, the little words, little details. So you get 26 out of 16, 26, 67%. So Sisler is overall most likely to win. Of course it is. Of course Sisler is always more likely to win. I'm not biased at all. The odds of being struck by lightning, here you have odds, state the probability against being struck by lightning. Because it's for lightning, right? This is lightning, that's not lightning. So the not is what you want to put on top here. Okay, the not, because it's probability against lightning. So you get 11,999 over 12,000. The odds, listen to this one carefully, the odds against, I literally just flip this one, because I already have the odds in favor, I just flip it to go against. Okay? Out of 850,000 people, how many are likely to be struck by lightning? I use the 1 here. This is the probability of lightning. over 12,000. Where did I get the 12,000 from? I just add these two. So I'm making a prediction. So you get this as a decimal, but approximately 71 people get struck by lightning. That's a lot of people. Stay out of the field, out of high areas. Okay, I'll stop this here. We'll do the test.